using in polar coordinates. In particular, we're looking at area and arc length. Okay, so this is so those are the two things. So area, I guess this is the area formula right here. Area and then the L is the arc length. Okay, so this is the area and this is arc length, or length of a curve or whatever. Okay, so first of all, we'll deal with the area and kind of try to explain a little bit how that works. So if you have a wedge like this, so think of this as maybe part of a circle. Okay, think of it as part of a circle whose center is right here. And if this is the radius r, right here, this part right here is r theta. And so this piece right here is kind of like a triangle. And the area of a triangle is 1/2 the base times the height. And so essentially, the base is basically r theta. When you're really small, or if you're really small, or r d theta. So this angle right here would be d theta. So your base would be r d theta. And your height, wait, I got that backwards. So probably it's best to think of the base as being this right here, the r, and this height as this being the height. Okay, so in other words, the base and the height. And the area of a triangle is 1/2 the base times the height, so you get 1/2 r times r d theta, which gives you this piece right here. And that's why it's that's where this formula comes from. Okay, now that's essentially where this formula comes from. This is the main formula. And let me show you how it's used in action. So and the context is usually that your r is equal to f of theta. Okay, so like for example here with number 1, your r is 7 cosine theta. Okay, so this is f of theta. R equals f of theta. R is 7 cosine theta. Okay, so it says find the area of the region bounded by the graph of the polar equation that lies in the specified sector. So when theta goes from 0 to pi/6. Now, with most of these problems, it's always a good idea to graph them first. Okay. It's always a good idea to graph first. Because sometimes weird things happen, and when you're dealing with polar coordinates that are unexpected, that you wouldn't know about if you're just looking at the equations. So like, for example, if this r goes negative somewhere, then how do you deal with that? Okay, so you're going from 0 to pi/6. So if we put in, so we can get some values of r here for different values of theta. So 0 is probably, since that's the starting point, when we'll start with 0. 7 cosine 0 is actually 7, because cosine 0 is 1, so that's 7. Okay, so that gives us the point, the angle's 0, and you're out here at 7. And then when theta is pi/6, we have 7 cosine of pi/6, and cosine of pi/6 is, let's see, 1, 2, It's just kind of an angle here. So the cosine is root 3 over 2. So that's 7 root 3 over 2. Okay. And so when you're at pi over 6, which is maybe right here, then this distance right here is 7 root 3 over 2. Okay. And so your curve's going like that. And so essentially, we want to know what this area is right here. So kind of like a piece of pizza, but with this side kind of distorted. I set one into the oven wrong. Okay, so we will apply the formula. So limits of integration. Well, let me just write the formula down first. It's 1/2 f of theta squared d theta. Okay, so your limits are 0 to pi over 6, and you're squaring this right here. So this is going to be 49 cosine squared theta. Okay, so I just squared that d theta, and I can pull the 49/2 all the way out. Let me try to draw a little bit neater here. There should be an example of when you guys do the homework. Okay, cosine squared is 1 plus cosine of 2 theta all over 2. Okay, and so I'm gonna pull this 2 out here with this other 2 fourths, and then take antiderivatives. The antiderivative, that's theta, and this one is sine 2 theta, 1/2 sine 2 theta, because you take the derivative, you get cosine 2 theta. Okay, so then when I plug stuff in, I plug the upper limit in first, so pi over 6 plus sine of, let's see, if I have a pi over 6 here, I got pi over 3, sine of pi over 3 over 2. Okay, that's the upper limit. Now when I plug the 0 in, I get 0 plus sine 0. Okay, that's sine 0. So that's so that part all is just 0. Except, let me put a better 0. There, that's a better looking 0. Okay, so let's see what this is going to be. Sine of pi over 3, let's see. Pi over 2 is going to be like this, 1, 2, root 3. So sine will be root 3 over 2. This is root 3 over 2. So that ends up being root 3 over 4, actually. And that looks like that answer will work. Maybe you could put it like this. Factor another 2 out. Like that. That would work. You guys got any questions about that? Okay, if not, we'll move on to the next exercise. So more of the same. Here, number 2, we're supposed to find the area of the shaded region of r equals 4 plus 3 sine theta. And here they've been nice enough to graph it for us. So what we need to do is figure out what the angles are. And I think you can figure out from here. This is when theta is negative pi over 2, it looks like, is this one right here. And r is going to be 4 plus 3 times 3 sine of negative pi over 2. And that's negative 1, by the way. So this is just going to be 1. So r is 1. And then this angle going up here where you have pi over 2, r is going to be, I guess I don't have to write that. I have to write that way. R is going to be 4 plus 3 sine of pi over 2, which is going to be 7. Okay? So that's why this is 7 right here. So it looks like your limits of integration are going to be from negative pi over 2 to pi over 2. And 1/2, and then you square this right here. Okay, so let's go ahead and come down here. This is one of those cases where, usually a lot of times when you're dealing with sine and cosine, then you can like just go from 0 to 1/2 and double it, but you definitely can't do that here because this area here, this is going from negative pi over 2 to pi over 2 to 0. This area is much less than this one, so you definitely can't do that this time. Okay, so I'll go ahead and square all this. And I have, what's that, 16 plus, okay, multiply this, that's 12 times 2, that's 24 sine theta. And then the last one squared is 9 sine squared theta. So we have 16 plus 24 sine theta. And here we're going to use the trigonometric identity that sine squared theta. Let me write it in a different color. Equals 1 minus cosine 2 theta over 2. Okay, so that's using that identity. Minus 9 cosine 2 theta over 2. And that's all times g theta. Ooh, really cutting it close on the space there. Okay, so we have 1/2. And we can go ahead and integrate now. This gives you 16 theta plus, okay, and integral, this one's going to be, or that's going to be minus minus 24 cosine theta, because when you take the derivative, you get negative sign. So the negative there gets taken out. Then plus 9/2 theta, and then this one is sine 2 theta. Okay, so when you take your derivative here, you get a 2 coming out, so you want to have a 4 down there to reduce that, and then you have a 9. So that goes from negative pi over 2 to pi over 2. Now, one thing that's really nice is when you put pi over 2 into here, you get 0. And when you put negative pi over 2, you also get 0. So I'm not even going to mess with that. Also, because there's a 2 right here, when you put pi over 2 in here, you get actually sine of pi. And this one gives you sine of negative pi. And those are both 0. So you can just wipe that out right immediately. Even before, writing it all out. Okay, so you have 1/2, and then you've got 16 pi over 2 plus 9/2 times pi over 2 minus, I'll put in brackets here, (16 times negative pi over 2 plus 9/2 times negative pi over 2. And I get 41 pi over 4 when I simplify that all the way out. Okay, any questions about that or comments? Okay, moving along to number 3. Sketch the graph of the polar equation r equals 5 plus 4 cosine theta, and we also want to find the area that it encloses. And so, as usual, what we're going to do first is make a chart here where you have values of theta and values of r. And the first value is 0 typically. I'll plug in a 0 because there's no value, there's no specification on the range of theta. So we'll do 0 first. Cosine of 0 is 1, so this is going to be 9. Okay, so when you're going out in the positive x direction, you want to be at 9, and this one works right here. This one doesn't because it doesn't go through 9, and this doesn't go through 9, and this doesn't go through 9. So this is pretty much it right here. And we can put some other values in. So maybe pi over 2. When you put pi over 2 in here, you get 0, so that should be 5. And indeed, it's at 5. And when you put pi, cosine is -1, so you actually get 1. So yeah, you're at 1. Wait, what am I doing? This is this one. That one point is correct, but that one is. But this graph is wrong. So it's this, and then pi, it's at 1 because this distance is 1. And then if we go to pi 3 pi over 2, then that's going to be 0 also. So it's at 5 right here. Okay, so it's this first graph right here. Now we want to find the area that encloses. And the nice thing is that going from 0 to 2 pi will cover the whole thing. So it's 1/2 all this squared. Okay, so 0 to 2 pi, square all that, you get 25 plus, if you multiply these together, you get 20, that's going to be 40 cosine theta, and then the last one squared at 16 cosine squared theta. And again, we're going to use this identity. That's 1 plus cosine 2 theta all over 2. Okay, now there's a 16, so that just basically cuts it down to 8. Right there. Okay, so 16 divided by 2 is 8, and then you attribute the 8 to there and there. So we get that. And let's see, let's go ahead and integrate. But first of all, keep in mind that the 25 and 8, that adds up to 33. So that's, and then when you integrate it, you're going to get 33 theta. Okay, so that becomes 33 theta. And then this one is 40 sine theta. And then this one is, okay, if you integrate, you get sine 2 theta. Let's see, derivative of that will be 2 sine 2 theta, but you want it to be 8, so just put a 4 there. And that goes from 0 to 2 pi. Now, it's really nice at this point, because if you put a 2 pi into here, sine 2 pi is 0, sine of 4 pi is 0, and then the zeros also gives you 0 and 0. So those ones, those are just going to be 0, because both the upper and lower limit gives you 0. And so we have 33 over 2 times 2 pi minus 0. So that's 33 pi. Any questions about that? I think this one was really similar to the last exercise. So anyways, let's go on to number 4. Sketch this graph right here. So here we have 1 plus cosine squared, the square root of 1 plus cosine squared of 5 theta. Okay, one thing that you can notice right off the bat is because you're squaring this right here, it's going to give you a number that's greater than or equal to 0. So the smallest this can be is 0. And so you're taking so the smallest this can be is 1 actually, because it's the square root of 1 plus 0. That's the smallest it can be. So that means that these two you can just throw those out. It's not going to be either of these because it never gets to 0. It never, in fact, if you draw a circle around here, it looks like based on just that idea that you have a trigonometric either a sine or cosine squared right here, that means that these two are options, or it could be one of those two. You're not going to get inside the ring right here of the circle of radius 1 at the origin. Okay, but you don't need to understand that. We can always just plot some points. So if you say, okay, if theta is 0, then we have the square root of 1 plus cosine squared of 0. Now cosine of 0 is 1. Squared is going to give you 1, so that's going to be the square root of 2. Okay, so this starting point out here is going to be at root 2. This is at 1, so that's off. And this looks like it could be root 2 though. But this is definitely not it. So that's out. And then this point works. The next thing that you would probably do would be the next point that you choose. So we already know that this is going to be the graph. But if you're just graphing this on your own, then the next point that you might want to choose would be now usually you'd be like pi over 2, but if you put a pi over 2, you get 5 pi over 2. So what you want to do is you want to put a value of theta in that is going to make it so you're taking the cosine of pi over 2. And pi over 10 will do that. So if you go to pi over 10 here, okay, pi over 10, then when you put that in here, you're taking the square root of 1 plus cosine squared of pi over 2. And that's a really bad drawing there. And cosine of pi over 2 is 0, so that's just going to be 1. Square root of 1, which is 1. Okay, so 0. So when and now it's going to be this angle here. Okay, so that's going to be pi over 10, that angle right there. And we'll give you that point there. And so then you can kind of see that it's going to fluctuate like that. Okay, as you go to pi over 5 would be next, maybe that one there. And as you go along, then if you're a pi over 4, then it's going to swing back out to root 2 and so on, and just kind of go like that. So that's what the graph looks like. Okay, so now the next thing you want to do is you want to find the area that encloses right here. So again, we just use the area thing. The important thing is to know that this goes from 0 to 2 pi again. I'll put the 1/2 out there. And then when I square it, it's just going to be squaring this right here. So that gives me that. And then, of course, that's just 1 plus cosine squared of 5 theta. And again, we're going to use the the identity, cosine squared of theta. Let's use an x this time because we don't have a theta right here.
Does this happen a lot in these problems where we have to utilize this identity or the sine squared identity?
Yeah. I think this is the last one though, or that does that. But I mean, this comes up a lot in here. It's just kind of you kind of feel like they're purposely doing problems that you can actually solve. They can actually take the integral. Okay, so this is going to be 1 minus cosine of 10 theta. Okay, so if x is 5 theta, then 2x is 10 theta. That's all over 2. Okay, so let's see here what we got. I think I can factor another 2 out, so that makes it 4 then. And that becomes 2, and this is 1. So this is going to be 3 minus cosine of 10 theta. And now we can integrate. We have 3 theta here minus sine of 10 theta over 10. And that's going from 0 to 2 pi. Okay, so again, if we put a 2 pi into here, it's sine of 20 pi, which is 0. And if you put a 0 in, you're also getting 0. So that's, both limits are going to give you 0. And then if you put the 2 pi in, then you get to 2 pi there. If you put a 0, that's going to give you 0 also. So the answer is going to be 1/4 times 3 times 2 pi. So that's 3 pi over 2 for the answer. Any questions?
Yeah, quick question.
Yeah.
The 3, where did that come from again? When we took the 2 out?
Yeah, let me be more clear about that. So this right here is 2 halves. This right here is 1 half. That's 3 halves. The 2 went out here though. The 2 went out there.
Okay, now it makes sense. Thanks.
Sure. Okay, so number 5, one more problem, I guess. Find the R. Oh no. This should be find the area. A typo, I made a typo. Okay, so find the area of the region enclosed by one loop of R equals 2 sine of 9 theta. Okay, so here in this problem, what you have to do first is figure out how much one loop is. What are the limits going to be? You can't just say, oh, I'm just going to go from 0 to 2 pi. That's going to mess you up. I think if you do that, then you're probably going to get it wrong. So you have to figure out how much one loop is. So let's see. So you can start by putting values of theta in. And start with 0. That gives you 0. Okay. So, and then also while you're doing that, graph. So when you put a 0 in, you're going to get 0. Okay. So it just be this point right here at the origin. So that's the positive direction, gives you 0. Okay. Now choose another value. For the next value, it's good if you make it so that this turns out to be 9 pi. So this turns out to be pi over 2. I'm sorry. So 9 theta equals pi over 2. So theta would be pi over 18. Okay, so we're going to put pi over 18 in. And that way you're taking 2 sine of pi over 2. sine of pi over 2 is 1, so that's going to be 2. Okay, so that's giving you the point pi over 18, 2. Now, pi over 18 would be an angle, would be a really small angle like this. And we'll say that's 1, 2. We'll say that's 2. Okay, so in going from as your angle sweeps from 0 up to pi over 18, your curve starts with the origin and goes up to there. Okay, and then when you get to 2 pi over 18, or which is pi over 9, then you're taking, then it's going to be, let me do it a different color. Then it's going to be 2 sine of pi. Okay, so maybe I should have done it. Let me do this. I'm going to put pi over 9, which is double that, but you know. Okay, so when you put a power over 9 in here for theta, you're going to get pi, sine pi, and that's 0. Okay, so when you're at pi over 9, you're back at 0 here. Okay, so that's going to swing back around that way. Okay, so that's one loop, so the loop goes like that, and it's covered. So one loop is covered from 0 to pi over 9. Okay, I guess that's the main part right there. Just trying to figure out what that would be. So you're integrating from 0 to pi over 9 gives you the entire loop. Okay, so then just square that. So that's 4 sine squared of 9 theta d theta. Oh boy. 1/2 times 4 is 2. Well, isn't that nice? That times that is 2. So I'll just put the 2 in there because we're using the formula sine squared x is 1 minus cosine of 2x all over 2. So you get that. And then, yay, the 2's are going to cancel. That's really nice. So we just basically have 1 minus cosine 18x, antiderivative theta. And then let's see, sine of 18. It should be a theta, not an x, sorry. Sine of 18 theta over 18. Wow. 0 to pi over 9. Okay, if you put a pi over 9 in here, you're going to get sine of 2 theta. If you put and then if you put a 0, and you're also going to get sine of 0, which is all that's a 0. So that's just going to be 0, and so then you end up with pi over 9. That's it. Because putting a pi over 9 here gives you pi over 9. Okay, any questions or comments about that? Okay, let's move to the next one. Okay, number 6. Find the area of the region that lies inside one curve and outside another curve. Okay, so let's do this one in blue, and let's do this one in green. Okay, so first of all, we have to figure out what the limits are and whatnot. So the idea, the underlying idea will be this though. But if you want it inside one curve and outside the other, then your area is going to be something like this. So inside this and outside another. Okay, it'll be the blue one. So inside the blue one, outside the green one. So the blue one minus the gray one. Okay, so we need to figure out what these limits of integration are. That's the main thing, but if you're inside the blue one, that means the blue one is the outside boundary actually, and outside the green one, that means the green one's the inside boundary. Okay, now let me do a picture just so that to better give you an explanation of why this is the case, why you want to set it up this way. Okay, so if I put a 0 in, then the cosine 0 is 1, so that's going to be 2. If I put a pi over 2 in, then I have, that's 0, so this is just going to be 1. And if I put a pi in, this is going to be 1 plus cosine pi, that's 0. And if I put a 3 pi over 2 in, then this is 0, so it's just going to be back to 1. Okay, so that's that one. And let me go ahead and graph it over here. So 0, your angle is 0, you're out here at 2. When you're at pi over 2, you're back at 1. When you're at pi, you're at 0. And when you're at 3 pi over 2, you're back at 1. So it's right this way, so you're going 1 in the bottom direction. Okay, so your graph is going to look something like this. It looks like a sideways heart. We should make this red and do a Valentine's poem or something, but I'm too lazy for that. Okay, now the other one, the green one. So here we have, let me give myself just a little bit more space just in case. Okay, so when theta is 0, this is 1, so it's 1. Okay, so it's at 1 then. One is supposed to be halfway between 0 and 2. Okay, and when theta is pi over 2, this is 0, so it's at 2. So this is up here at 2. And when you're at pi, this is -1, so this is 3. So you're way over here at 3. And when theta is 3 pi over 2, then this is 0 again, so you're back at 2 again. Okay, so this one goes something like this. I don't know. Okay, so we want the area that is outside this one. So that the outside would be all of this, including in here. And inside the blue one, is just in here. So the intersection of those two areas is going to be this right here. And these are symmetric. So what we could do is just go from here to here, whatever that angle is. So what we need to do is figure out, what this angle is right here. What we could do is go from 0 to whatever this angle is and double it. Okay, or we could go from this angle to that angle, and just keep the 1/2 there. But it's easier if we go from 0 to here and double it. So that's what we're going to do. But we need to figure out what this point is right here. Okay, so to figure that out, where they intersect, to figure that out, we set these equal to each other. Okay, so 1 plus cosine theta equals 2 minus cosine theta. Okay, bring this over here, and that gives us 2 cosine theta. Subtract 1 from both sides, and it gives us 1. So cosine theta equals 1/2, and that is going to be 1 Let's be where you have 1 right here and 2 right there. So this is angle is pi over 6. Okay, great. So now we know it's from pi to pi over 6. So that means we can go from 0 to pi over 6, double it, gets rid of the 1/2 of all this. Okay, so let me go ahead and expand this out. That's 1 plus 2 cosine theta plus cosine squared theta. Okay, and then expand this one out. That's going to be 4 minus 2 times that is 4. So that's 4 cosine theta plus, and then squaring that is cosine squared theta. D theta. Okay, so let me explain that. So instead of negative pi over 6 to pi over 6, use 2 and then go from 0 to pi over 6. Okay, right here. Which essentially, all that basically did was eliminate the this 1/2 on the front here. Okay, great. So let's go ahead and figure things out here. So you have a cosine squared minus another cosine squared. So those are going to cancel each other right there, right off the bat. So yeah, we don't have to worry about using that pesky formula again, unless you guys really liked it. I didn't really like it that much. I guess it's really nice and I appreciate it, but okay. So we have 1 minus 4. So that's, whoa, that's -3. I don't know. And then 2 cosine theta minus a -4. So that's going to be plus 6 cosine theta d theta. Okay, so integrate, and we have -3 theta plus 6 sine theta from 0 to pi over 6. Okay, put a pi over 6 in, you get -3 times pi over 6 plus 6 sine of pi over 6. And if you put a 0 in, you get a 0 there, and sine of 0 is also 0, so that's 0. So let's see, we have I'm sorry, this is not pi over 6. This is, I knew something was wrong. This is pi over 3. This is pi over 3. What am I thinking? So, okay, so this would be negative pi, and then sine of pi over 3 will be √3 over 2, so that's plus 6 times √3 over 2. So that's negative pi plus 3 root 3.